Now we are going to see PN junction diode characteristics. So here what we are going to do is to plot VA characteristics of a PN junction diode and cut-in voltage of a PN junction diode and static and dynamic resistances for forward as well as reverse bias of a PN junction diode. So components required for PN junction diode is, see, PN junction diode and resistances. For forward bias it is of 1 kilo ohm resistance, and for reverse bias we are taking 10 kilo ohm resistance. And after that, breadboard, dual channel regulated power supply, okay, RPS, and voltmeter of 0 to 30 volts and ammeter of 0 to 200 milliamps. So these are the components required for doing the PN junction diode. So how to do the PN junction diode? See the circuit here. Now first of all we are going to do PN junction diode forward bias. So here we need RPS, resistance, and ammeter, voltmeter, PN junction diode, and a closed circuit. So first of all we are going to check whether this resistance is of 1 kilo ohm resistance or not. So first, for that one we have to take multimeter and put this value into 20 kilo ohm resistance. Resistance symbol is there, no, 20 kilo ohm resistance, and check the resistance value. It should be of 1 kilo ohm resistance. There will be a tolerance of 5%. So plus or minus 5% tolerance. So now it is of exactly 1 kilo ohm resistance, right? So we are going to take 1 kilo ohm resistance and diode. If you observe diode, one side there is a white color and other side there is a black color. The more black color which is there is considered as anode, and the little white color which is having is considered as cathode. So I am putting anode left side and cathode right side on the breadboard. And resistance also, I am taking resistance. This also I am putting the terminals on the breadboard. Okay, now connections. So if you see the circuit over here, here's the circuit. First, from the RPS positive, that is from RPS, see, before only we have to connect all these terminals such that it will be easier for us. So from the RPS positive terminal we have to connect the resistance. So in the same line you have to connect the resistance. So these two are connected. After that, from the resistance ending we have to connect ammeter. So ammeter positive we have to take, and this should be connected to resistance ending. From resistance ending it is going to ammeter positive, and the ammeter of 0 to 200 milliamps, and ammeter negative to diode anode side. So diode line we have to connect diode anode side. After that, from diode cathode we have to close the circuit. So from diode cathode, so I am taking one more wire, and from the cathode, okay, from the cathode I am connecting to the RPS negative. See, from the cathode the wire is going to negative, so RPS negative. The circuit is closed, circuit is over, and we have to connect voltmeter across the diode. So at anode side we have to connect positive, and cathode side we have to connect negative of the voltmeter. So these are the connections. Now we have completed the connections. Now switch on the supply, and then first in the RPS there is a current. So put the current full, current limit. This should be kept full. After that, start moving the supply. So now check the tabular column. In the tabular column, how you are going to connect? See, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. After that 1.0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 10 volts we are going to take down the connection. So this is the RPS, regulated power supply, and here we are going to take voltmeter reading, and here we are going to take ammeter reading. Now adjust this slowly up to 0.1. There is a 0. Now the RPS value is 0.1. So what is the voltage here? We are getting 0.3 volts, and here there is no current, that is 0.0. And after that adjust the so 0.2, right, 0.2. So what is the value for 0.2? 0.4, and the current value is almost 0.1. Okay, it is fluctuating. Now after that 0.3, 0.3, the voltage in the voltmeter is 0.5, and the current is 0.1. Slowly you have to do pause. So from like that you have to continue. So 0.8 we are getting almost 0.9 also we are getting. For 0.9 we are getting 0.6, and here we are getting 0.7 amps, 7 milliamps. Next for 1, so for 1 RPS value it is getting 0.5. It is varying up to 0.5, 0.6 like that, the voltage, and here we are getting 0.8 milliamps. Next for 1.1, now we are going to take 1, 2, 3 digits. Now we are going to take 2 value. For 2 volts we are getting 0.6, and here we are getting 1.8. For 3 volts, we are getting 0.7 volts, and here we are getting 3.0 milliamps. Okay, next for 4 volts, we are getting 0.7, and here we are getting 3.8 milliamps. Next for 5 volts, also we are getting 0.7, and here we are getting 5 milliamps. Next 6. So you have to continue up to 10 volts. Next 7. So for 7 volts we are getting 0.7, and here we are getting 7.1. For 8 volts 0.7 and 8.1. For 9 volts 0.7, and here also 9.4. For 10 volts last value we are going to take for 10 volts is of 0.7, and we are getting 10.4 milliamps. Okay, these are the values we got. Clear? Next we have to plot the graph. So for plotting the graph, okay, now till now we have done forward bias. We are taking x-axis as forward voltage. So forward voltage means 0.3 to 0.7. So what we can take 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 and 0.7. So up to 0.7 you can take. And here coming to the current, it came up to 0.0 to 10.4. So here I am going to take 0.5, 1, 2, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, like that up to 10 volts, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5 up to 10 volts. So here if you observe carefully, by taking the readings of these two, forward voltage and forward current, you are going to get the graph. First of all, it starts from this point, 0.3. That means forward voltage is 0.3. So it is starting from here. That means up to here it is of 0 only. So here first we have to take for 0 also. So the value is from 0.0. So from this point here up to here it is 0. After that for 0.3 0.0 only. For the 0.4 0.1. That means a little bit up. So slowly it will be going like this, like this, like this, and from 6 to 7 it takes a curve. See here, from 6 to 7, okay, the voltage is rising so drastically, 5, 0.5, 0.6, 0.8, 1, 3, 5. So for 7 it is increasing. So it remains on the 7 only, but the graph is going to rise like this. Why we are getting? Because this is a cut-in voltage. Cut-in voltage. So by seeing this also we can decide whether it is a silicon diode or a germanium diode. For silicon diode, the cut-in voltage is 0.7. If you take a PN junction of germanium, the cut-in voltage is 0.3. That means the waveform will be coming from here itself. So by seeing this 0.7 cut-in voltage, we can decide that this diode is a PN junction diode of silicon, made up of silicon diode. Okay. So this is the graph you have to draw. After that, we have to find out static forward resistance. So from the origin, you have to draw a straight line. You can draw anywhere, which is by touching this graph. So wherever the point you are getting, there you have to find out the voltage, that is something 0.69 or 0.65 and 0.45. So you have to take VF by RF. See, static forward resistance is nothing but VF by RF. So VF is from this point, it is coming up to 0.69 VF value, and RF value is, that is IF value is 5. So this is the static dynamic resistance value. If you want to take dynamic resistance, draw a straight line which has to touch 2 points, this point and this point. This point will be considered as V2 I2 and this point is considered as V1 I1. So here according to the formula, dynamic forward resistance equal to change in VF by change in IF, del VF by del IF, that is V2 minus V1 by I2 minus I1. So you have to take V2 value from here and V2 minus V1 and I2 minus I1, such that you are going to get dynamic forward resistance. Okay. 3 to 1 into radius. Now we are going to see reverse bias of a PN junction diode. In the reverse bias, we need 3 things we need to change. Already we have done this experiment. Now again we have to put all the RPS values into 0 position, all the knobs into minimum position, 0 position, and switch off. Okay, once we have switched off, then now we are going to do reverse bias, which is very easy if you understand the three things. What are the three things? First thing, instead of putting 1 kilo ohm resistor, replace it with 10 kilo ohm resistor. Instead of putting 0 to 20 milliamps, replace with 0 to 200 microamperes. Instead of connecting positive wire to resistance and negative wire to diode cathode, change the supply terminals. That means negative should be connected to resistance and positive should be connected to cathode. Okay, so that means supply terminals should be changed, resistance values should be changed, and ammeter should be changed. So these three things you need to remember, such that the connections are very easy. So how this is a PN junction diode forward bias. Now I am going to change the connections. Observe it carefully. First thing, supply terminal should be changed. Here positive is there, here downwards positive is there. So these are the supply terminals. So this terminal should be replaced, this should be kept at a resistance place, and the negative terminal should be kept. So supply terminals have interchanged. Okay, that means this is over. Next, replace 1 kilo ohm resistance with 10 kilo ohm resistance. So this is 10 kilo ohm resistance. We will check this whether it is of 10 kilo ohm resistance or not, and see here. Yes, it is of 9.8, almost 10 kilo ohm resistance. As we are having the tolerance, it will be showing a slight difference. So taking off this resistance and putting 10 kilo ohm resistance instead of 1 kilo ohm resistance. Yeah. Now I have changed the resistance value also. Next thing is change this knob to 200 microamperes. See this, 200 microamperes. Right. So these are the three changes you have to do. After that, again switch on and put the current limit to maximum. Okay, after putting current limit to maximum, okay, current limit to maximum, then you have to slowly vary the values. I will show you. Just vary 1 volt in RPS. See, vary 1 volt here and note down the readings, the voltmeter reading and current reading. See here, voltmeter reading is minus value and current reading also minus. As we are doing reverse bias, all the values will be showing as negative. So here voltage value is 1.3 and current value is 1.2 microamperes. Now again move it to 2 amps, 2 volts. The voltmeter reading is 2.3 and current reading is 2.2 microamperes. Like that you have to continue the readings. So these are the readings. See, for 4 we are getting minus 4.3 and minus 4.3, and for 8 we are getting minus 8.3 voltage and minus 8.4 microamperes. Like that you have to take down the readings. So after that we have to draw a graph for this one also, for the reverse bias. So for the reverse bias, the graph will be coming almost like this. Okay, so here this is of IR reverse current, and this is of VR reverse voltage. And for this also draw a line at one point, and here you are going to find out static reverse resistance. Okay, and next you have to take 2 points, 1 point here and 1 point here, and we have to take this one as V2 I2 and this point as V1 I1. And for dynamic reverse resistance, okay, V2 minus V1 by I2 minus I1. This is the formula. Here is V by I. So like that you are going to find out the static reverse resistance and dynamic reverse resistance. So like that we are going to find out the values. Hence we have plotted the diagram and we have found out the static reverse resistance, dynamic reverse resistance. So here, like this we are going to complete the entire things. Like we have plotted the VA characteristics, and we have find the cut-in voltage in forward bias, and we have find out the static and dynamic resistance for both forward and reverse bias. This is how we have proved the circuit.